Hello, future engineers, subscribers, viewers, and students. Here is the solution to the quiz problems, particularly on the topic about 2D trusses. So this is the problem given in the 740 to 910 MW class. For the truss shown, determine the bar forces of BC, BE, and DE, and indicate if the bar force is tension or compression. So for the first part, take note that we have BC here. If we want to solve for BC, all we have to do is cross or section this part. Two members will be horizontal, only one is vertical, and we can easily solve that. This is now the resulting free body diagram. This is member CE, this is member AB, but we are interested of BC. All these members are two first bodies for truss members. So summation forces vertical so that these two horizontal forces won't be involved in the static equation. So summation forces vertical equals 0, downward positive. So we have SBC downward treated positive, another 300 treated positive equals 0. So SBC is negative 300 pounds. The negative sign indicates that the stress in BC or the force in BC is compression. So the answer is 300 pounds compression. Next, for BE, we have to introduce the section because the reaction at B is involved. We have to solve for the reaction at B first. Considering the entire system, we sum up moments about G equals 0. So this one is 300 to the right, obviously by summing up forces horizontal. So clockwise positive, reaction at B times 18. Everything is counterclockwise, so equals, beginning with 900, 900 times 6, plus this 300 here times 8, then plus this 300 here times 12 plus 12, 24. So reaction at B is 833.33 pounds. We then draw the free body diagram of all forces to the right of this section, and this is now the free body diagram. We have CE, we have BD, and this is BE, SBE. The slope of BE would be 6 horizontal, 8 vertical, which is reducible to 3 horizontal, 4 vertical, so 5 hypotenuse. Again, so that all these two members here won't be involved in the static equation, we have to sum up forces vertical. The vertical component of SBE is SBE times 4 over 5, then plus 833.33 minus 300 or equals 300. So solving for SB, it is negative 666.7 pounds. The negative sign indicates that it is a compression member. So the final answer SB is 666.7 pounds, and it is compression. Finally, for DE, we have to introduce this section again so that two members will be horizontal, one is vertical, so we can solve for this vertical member by summing up forces vertical. And this is the free body diagram. There's no need to name the other two section members. They are not involved in the summation of forces y equals 0 as equation of statics. So summation forces y equals 0, 833.33, then minus SDE minus 300 equals 0. Solving for SDE, it is 533.3 pounds. Because it is positive, it is tension. So continuing, this is the class given as quiz for the 9:20 to 10:50 a.m. MW class. So for the truss shown, determine the bar forces of members marked as 0.1, 2, and 3. So if you have to take a cursory look, we can always pass a section through 3 members. Do not pass that section, there are 4 members cap, but through this path. like that. So this is the section, and we draw the free body diagram of the upper part. The free body diagram of the upper part should be considered. So this is now the FBD. The force considered would be just this 90 pounds. So because the members passed through this section are considered tension, so I'll call this SB. This is S2 originally, this is SA, and the joints I also name it or label it as A, this one is B. So summation forces horizontal, because these two are vertical, equals 0. There's no other force that is horizontal above this section here, so therefore S2 is 0. Then to solve for the force in 1, we have to consider this joint by solving SB first. We can solve SB, remember S2 is 0, by summing up moments about A. So summation of moments about A equals 0, considering this same section and above it, forces above it. So we have this equation S sub B counterclockwise positive times 3 meters, so that's 3 meters. S2 is 0, so don't mind. Then plus 90, also counterclockwise about A, times 1 equals 0. So SB is negative 30 kilonewtons. Then we draw the free body diagram, which is joint of this joint B. These are the involved forces, S1. Then S of C, I just call this S sub C. Same slope, just copy that here. 3, 4, 5. 3 because I double 1.5. 4 because I double 2. This is 2 meters times 4. So summation forces vertical, so that S1 would be involved, equals 0, and considering downward positive, the vertical component of S sub C is S sub C times 3 over 5, then plus negative 30 equals 0, so S sub C is 50 kilonewtons. Finally, to solve for S1, summation forces horizontal equals 0. S sub 1 plus S sub C, horizontal component of S sub C, is S sub C, which is 50 times 4 over 5 equals 0. So S sub 1 is negative 40 kilonewtons. Finally, we have to find the force in number 3 by isolating this joint and drawing the FBD. Remember that S2 is 0, so you just remove it from the free body diagram. We have the load 60 to the left, then S3 here. The slope of S3 is 1.5 vertical, which I double, it becomes 3. So I also double 1, so that's why it's 2. So the hypotenuse is square root of 13. For this member here, which I call SD, the slope is the same. 2 horizontally make it 4. 1.5 vertically make it 3. So 3, 4, 5. So summation forces Y equals 0. Then we have going down positive. Vertical component of S3 is S3 times 3 over square root of 13 plus vertical component of SD, SD times 3 over 5. Then no more equals 0. Call that equation 1. Summation forces X equals 0. S3 is going to the left, so its X component is negative S3 times 2 over square root of 13. Then plus SD times 4 over 5. And minus 60 equals 0. Minus 60 equals 0 is the same as equals 60. Equation 2. Solving these two equations simultaneously, we get S3 equals negative 36.06 kilonewtons. So that's it for this video.